Just a quick review on geometric sequences. Remember, when you have a geometric sequence, you will start with your first term. So my first term, say it's 5. And then each term, to get to the next term, you will multiply by a common ratio. We call that r. So I'm going to times -2 maybe for this particular one. So then my next term would be -10. And then I would move on times -2, and my next term would be 20. And times -2, and my next term would be -40, and it would continue on and on like that. So that's what makes a geometric sequence, the fact that you multiply each time. So if you get a sequence that looks, say, for instance, like maybe it is, I don't know why I'm taking so long to think about it, but it could be anything, 2, 12, 22, 32. When I look at this, this is clearly not multiplying, because it would be 2 times 6 to get 12, but 12 times 6 is not 22. And so we say that's not geometric. So if it doesn't have a common ratio, it's not geometric. Then we also talked about expanding a geometric sequence using the recursive form. The recursive form, and that's when you're given what your pattern is. So a sub n is equal to a sub n minus 1 times 3. And then you're given your first term, a sub 1 is 10, say, for instance. And so this is telling us where we start and how we change. So I'm going to expand this by writing the first term, 10, and then times 3, and then times 3, and then times 3, and then times 3. And so I would have my first 5 terms of my sequence. So that one is expanding. We also learned how to write the explicit form or explicit formula. I always call it form. Some places call it formula. So this is yet a different way. So recursive gives me the pattern. In explicit, I kind of write the pattern. So again, I'm going to go back to that original one that I did, 5, -10, 20, -40. And if I want to write it in the explicit formula, that form needs to have, I'm going to use a sub n equals a sub 1 times r to the n minus 1 power. And so I have to know the first term and what the pattern is. So when I write the explicit form for this one, it's a sub n equals first term times what I'm multiplying by to the n minus 1 power. And so then this would be my answer for that one. Whereas if I'm expanding using the recursive form, that would be my answer for that first one that we did. Okay. Lastly, we learned how to find the nth term. So find the nth term. And to do that, we need the explicit formula. So I have to be able to write out the explicit formula. And so let's say I'm going to change it up a little bit, and I'm going to do a different pattern. So let's say this one is -2 and 6, -18. That's all I need for this. And let's say I want to find a sub 11. I want to find that means find the 11th term. So I'll first write the explicit formula. A sub n is equal to the first term times the common ratio, multiplying by -3 each time, to the n minus 1 power. Remember, if you can't tell what the common ratio is, divide. 6 divided by -2 will give me -3. -18 divided by 6 will give me -3. So if you can't see it visually right away, then do that division. But then when I want to go ahead and find the 11th term like it asked for, so I want to find a sub 11, I would put 11 in. So this is -2 times -3 to the 11 minus 1 power, or -2 times -3 to the 10th power. And remember, we have to use our caret key for that. So I pull out my calculator, use your phone, whatever you need to do. I'm going to do -2 parenthesis -3. I always put parenthesis instead of times when I'm plugging it in, especially when there's a negative. So raised to the 10th power, then I hit equals, and my answer is -118098. So this equals -118098. All right, so that is the geometric sequence in review. Deciding if it's geometric, expanding a recursive form or formula, writing the explicit form or formula, and finding a particular term number. So good luck on your review. As always, have a great day. Let me know if you need anything.